We are now going to provide definitions related to exponential functions. So an exponential function is any function where the variable is in the exponent. And so this becomes really important because it's used quite a bit in the real world, especially with money matters and in a lot of very specific electrical work. And so this is what we're going to talk about. And the base is that number a, and it has some particular rules in relation to the exponential functions. Simply, it must be strictly greater than 0, and it can't equal 1. So as long as these two conditions are met, then this is an exponential function. Anytime the variable, and this is the key, anytime the variable is in the exponent, it's an exponential function. When we talk about exponential growth, we're talking about things like population growth. Things that grow more, that grow faster as there's more. So it's not linear. Bacteria in particular does this as well. We can use it to model the growth rate of rabbits, the growth rate of a population of a country. But it's because there's some number, a, raised to some power times some base amount that determines the growth. Decay, on the other hand, is typically radioactive decay. This is when it decays exponentially, or its half-life. No matter how much you have, half of it will be gone in a certain amount of time. That's what we're talking about when we talk about decay. Simple interest has a very simple formula. The interest is equal to the principal times the rate times the time, and the amount is equal to the principal plus the interest at some given time. So we can always figure out how much money we have with simple interest just by knowing how long it's been and what the interest rate is. Compound interest is a bit different. Compound interest is similar to the way that you repay loans, where it's calculated at specific times. And its formula is just a little bit more complicated. The amount is equal to the principal plus 1 plus the rate over some n raised to the nt power. And this interest rate is the nominal rate. This is the annual interest rate, but you don't pay all of the interest rate. It's not calculated every time you recalculate. It's calculated in n batches. So n is the number of times per year that you recalculate how much you owe or how much is owed to you. Now, this last one that we're going to talk about is the Euler number. I know it doesn't look like Euler, but that's what it is. And Euler was a mathematician in the 1700s who did a lot of work with these exponentials, and he came up with a number that seems to show up quite often. And so E is the number that the symbol that we use to represent this number. And E is equal to, or approximately equal to, 2.71828451818, there we go, 284945945. This is, and it keeps going, ... This is similar to pi. It's an irrational number, and it comes up quite a bit, and so you need to know what it is and how it works, and you need to know how to find it on your calculator as well. Now, the natural exponential function is a function that looks like e to the x. Instead of a to the x, it's e to the x. And we'll talk about how to use the Euler number and natural exponents here later on in this section.